With that, I'll introduce first speaker, Oliver Rubel, from Lawrence Berkeley National Lab, where they develop new standard for neurophysiology and other neural data, NWB. Thank you.
All right. Thank you, Yarek. Again, thank you for all the organizers for having me here. This is an amazing event. So I'm going to talk about Neurodata Without Borders, which is the neurophysiology data standard for the NIH Brain Initiative. In the spirit of this event, I want to try in this talk and keep the introduction to NWB brief and focus a little bit more on, what are some of the driving factors for change that drive our requirements, as well as what are some of the current ongoing developments, rather than presenting to you all the great things that we've done over the years. With that in mind, the things I'm talking about are not just from me. NWB is really a multidisciplinary team science effort driven by the whole community. And so what I'm going to talk about is work from lots of different people. We have Ben in the room, we have Cody Baker in the room, we have Ryan in the room, Matthew Avalon, and many others that are contributing to this effort. And so, to kick things off, what is NWB? Well, NWB, first of all, is a unified data standard for neurophysiology data that focuses on the dynamics of groups of neurons measured under a large range of experimental conditions. In NWB, we're covering a broad range of end-to-end data from neurophysiology experiments, from the ability to store the neural activity, from electrical and optical physiology recordings, to information about the data acquisition, the experimental design, such as your trial structure, stimuli, and so on, metadata about your subject, as well as recordings of the behavior of subjects. So all of that can fit into a single data file for a session, and then all these signals that you're recording are aligned in time in NWB. NWB also supports this concept of extensions, which allow users to integrate new data types with NWB, as well as custom metadata that is specific to the experiments. And so with that, NWB enables unified storage of multimodal raw and processed neurophysiology data. So in this example, we have an experiment where electrophysiology and optical physiology are recorded simultaneously. All that raw data can be placed in the same NWB file, and then from there on further processed through, for example, spike sorting and feature extraction. And again, the results can be placed back in the NWB file where all the signals are aligned in time. And because they are all in a consistent data format and aligned in time, it makes it easy then to analyze all these different signals in conjunction with each other, such as in this case, we have a segmentation of a neuron from the optical physiology along with the fluorescence signal, as well as the spiking signal from the electrical recording. But NWB is more than just a data format. It is really an ecosystem for neuroscience data standardization. And so as part of our core software ecosystem, we provide a broad range of tools, including tools for data conversion, such as NeuroConf and NWB Guide, as well as for inspection of NWB files through the NWB Inspector. We have our core data APIs in Python and MATLAB, PyNWB and MatNWB, which are being used both for data conversion, data access and analysis, as well as for integration with tools. We have a broad set of tools for managing extensions to the data standard, including our online catalog where users can share and publish extensions to the standard, as well as tools to help you create new extensions. We have our core data standard specification, which formally governs the data standard that we share and publish and develop with the community. And then we have underlying all of that, the hierarchical data modeling framework that we're developing that really builds the foundation for all the data modeling activities that we do. And then on top of that, we then have a growing ecosystem of tools and methods that are supporting and integrating with NWB. We now have a very vibrant ecosystem already of community tools that are integrating and supporting NWB, that are becoming accessible to you once you're adopting the NWB standard. We have tools for data exploration, such as NeuroAssistant NWB widgets. There's a broad range of tools for data management publications, such as Dandy Archive for publishing your data, DataJoin for managing your data, tools like Pineapple for doing data analysis, and then a broad range of tools that are specific to different modalities, such as for extracellular electrophysiology recording, such as OpenEFIS or Spike interface for spike sorting, analysis of optical physiology data, such as Cayman, Sweet2P, and others, as well as broad range of tools, for example, for analyzing behavior, such as Deep Lab Cut and Sleep for doing pose estimations. And so with this, NWB really provides a unified data standard and software ecosystem for neurophysiology. And so what are some of the drivers for change? So really what drives change and requirements for NWB are the growing and changing user demographics that we see, as well as the diversity of use cases that we're encountering in the community. So one of the key things that we do is really that we want to enable the neuroscience researchers to effectively utilize NWB and our software in their day-to-day work. We want to lower the barriers of adoption and promote broad dissemination. And so as part of that, we're conducting a lot of different user training and outreach activities. And so as part of that, we're getting to engage with the community. And when we started NWB at the beginning, right before, let's say, 2014 to 16, really it was about developing NWB. In NWB 2.0, which was between 2017 and 2019 development, right, engagement was really at the level of 50, 60 users, early adopters really that we were able to engage. And then now that we're in the second main phase of funding for NWB, we have a U24 grant for integration and dissemination. The focus has shifted to really a much broader community. And so now we're engaging with a much more diverse set of users. Every year we have 400 plus users at our events throughout the year. And so what that means is now we're engaging with users that have a much more diverse set of skills in terms of coding, from users that are professional software developers to users that don't know coding at all. We have a much more diverse set of career levels that we're engaging with, from undergrads, students to professional neuroscience staff. And then users have a much broader range of objectives that we need to meet that are really aligned across the different phases of the data lifecycle, from acquisition to analysis and publishing. And so what that means is that as these requirements of the community and the diversity of the community that we're engaging with changes, also our training events, our standards, and our software must adapt with these evolving changes of the community. That means creation of new types of events. So for example, last year we started the event for Neurodata Rehack for the first time, which really brings in users to take data that's published on the web and train them, as well as them conducting projects on reanalyzing data and deriving new knowledge and insights from that data. Or events like the Open Neurodata Showcase, where the generators of data present to the community the data that they have generated to engage other users in reusing their data. It also means new types of training resources, such as creating open data books, not just resources for training conversions, as well as new types of engagement with the community. Last year, for example, we now founded a technical advisory board in addition to our executive advisory board. We're also engaging younger generation through summer internships as well as other educational exercises. And then ultimately, also that means the standard in our software ecosystem needs to evolve with these changing needs. The other key aspect is that we're really dealing with living data. Data changes throughout its life cycle, from acquisition to processing to analysis to the time we publish and reuses. And NWB technologies are really sitting at the heart of this neurodata lifecycle. NWB as a data standard is a critical conduit that facilitates the flow of data throughout this data lifecycle and enables the integration of data and software across these different phases of the lifecycle. And so what that means for us is that NWB needs to support the needs of and integrate with technologies across all these different phases, right? And so that means data that goes through all these phases of the life cycle is not static, but it evolves throughout these different phases. And we, as a data standard, need to be able to deal with these different changes and be able to address these needs. It also means we need to flexibly integrate with a broad range of different technologies that are addressing different requirements across the different stages. Right? When we heard this morning the talks about large-scale data acquisition, the requirement there is going to be get my data as fast as you can on disk. But once we're then moving into later stages, such as spike sorting and analysis, the requirement is give me access to my data in the pattern that I want for my analysis. And then when we move to publishing data, we say, oh, now it's sitting in the cloud. Please give me access in a streaming fashion to my data. And all of those have very different requirements in terms of the software we need to write and the hardware that we're using. And so we need flexible approaches that can change and evolve with these kind of needs of the environment. And then another key driver is the fact that now we actually have public data on the web available, right? The Dandy archive now has 200-ish different Dandy data sets that have NWB data in them, including from large multidisciplinary efforts such as the IBL Brainwipe Map, the Microns recordings from the Allen Institute. And so there is a large body of data available now that provides a valuable resource for the community to do studies with. And so that also then drives changes in how we're actually interacting with the community and the data. And so we need new tools and features in NWB, for example, to support efficient streaming of data and cloud-based analysis, to enable the reanalysis of all that data. We need modular ways to access and store the data so that you can selectively get to the data that you want for your particular parts. We need abilities to link data with external resources, such as ontologies or persistent identifiers or even other data in different archives. Right? When we look at things like microns or IBL or all the data that BICCN is generating, there's multiple different types of data they generate that's distributed across many different archives. And ultimately, you want to be able to relate that neurophysiology recording with that electron microscopy recording or all the other kind of data that was acquired in those experiments. And so all these different factors and many, many more are driving all the different needs for NWB and the need to continuously evolve with what we do. And so just to give you an idea of some of the things that we're doing to address some of those needs, I just want to give you a sneak peek of some of the things that we're working on right now. Right? These are not necessarily all things that are widely adopted yet, but these are things that we're developing to address some of these needs. And this is really just also to give some food for thought and discussion as part of this event. Right? And that includes addressing needs on data storage as well as needs for creating new parts of the standard and new tools. And so, for example, to enable you to effectively utilize and access the public data that's on the cloud, we're working on methods to optimize the data storage for cloud-based access. That includes optimizing our current storage backend, which NWB currently uses HDF5 as its main file storage backend because it allowed us to collect large bodies of data in a single files that are easy to share. And so we're enhancing it to support streaming data access. We have various methods such as FSSpec as well as the RS3 driver. But we're also working on integrating with Kerchunk to further enhance streaming access in the cloud with HDF5. We're also working on, or have recently released earlier this year, HDMF ZAR as a new backend. So now you can store your data not just in HDF5, but you can store NWB data in the ZAR data format as well, which supports more modular data storage. It's optimized for cloud access, and it provides newer, more lightweight APIs. And so, for example, the Allen Institute for Neural Dynamics is actively exploring using ZAR with NWB in their storage strategies. And we're also working with other tools such as data join for managing data throughout the data lifecycle, and that includes efforts such as Spyglass or data joined elements. To address the needs of new data types and new types of metadata that we need to integrate, NWB supports the formal extension of the standard through formal schema extensions. And users can immediately use and share these extensions and write data with them. The extensions are being shared directly with the data in the NWB files. And then to share them more broadly with the community, we also have our extension catalog, so that we have a means to collaborate with the community and build new components to the standard. And then we have developed with our technical advisory board a formal process for enhancement proposals. So once you've created an extension, you believe it's broadly useful for the community, we have means to review those extensions and then also integrate them into the core standard so that the standard can evolve with the needs of the community. Some examples for this that are ongoing right now are extensions to store event-based data, to describe the structural tasks that are being used in behavioral experiments for pose estimation, as well as to describe probes. Another key effort is to make our tools more easy to use and accessible also to users who are not programmers. And so, for example, for data conversion, we always had our PyNWB and MetaNWB APIs, which allow you to easily write custom code to enhance your data, but they require coding experience and they require you to understand the standard. And so over the years, Catalyst Neuro has developed NeuroConf as a low-code automated conversion system for common input data formats that significantly reduces the amount of code you have to write, but you still have to code. And then more recently, Ryan Lee and Cody Baker and others are developing Guide as a new automated tool for data conversion that allows you to convert your data through an intuitive graphical app. And they're targeting a release of Guide for SFN as a first beta release. So I just want to give you a very quick sneak peek for Guide. Like I said, it's a graphical app. You can think of it as kind of like a TurboTax for converting data. So you start your new conversion project, and it allows you to then enter your basic metadata about your project, and it guides you step by step through the forms, asks you the questions about your data. And then once you have entered the metadata, it allows you to validate and review all the basic metadata that you entered. It will tell you where you're missing information or where something might be wrong. And once all that is validated, it will run a preview of your conversion. It will convert just small snippets of your data so that you can preview what is my NWB data going to look like. It's going to visualize it, and you can validate that everything is correct. And then it will, once you confirm, it will go off and automatically convert all the data that you want. And then once the conversion is done, it then also has the tools to directly upload to Dandy and publish your data, all through a graphical interface without you writing a single line of code. So that is going to significantly help to make NWB more broadly accessible to users who want to convert their data. The last effort I want to briefly mention is focused on integrating NWB with external resources. So in an NWB file, we store a broad range of data. For example, we specify what our species is, in this case, mouse. Now we want to formally describe what that actually means, and so we want to link that term to its description in NCBI taxonomy. We have a list of experimenters that are listed by name. We want to uniquely identify them through their ORCID or other identifiers. We're listing regions of the brain where electrodes are located. We want to uniquely identify them by linking them to the brain atlas. So these are all different types of linkages that we need to establish. And so, again, a little bit of a sneak peek of what we're working on. We're working on a data model and standard that allows us to annotate NWB files to support linking of individual terms to external resources. So what the it's the HDMF External Resource Data Standard allows you to do is to take a large collection of NWB files, identify the terms that you want to annotate, and link them to the external resources. You can do this with existing files as well as new data files. And it sits on the side of the NWB file and annotates it. So you don't have to modify your file to do these linkages. Just as a very quick example, here in the left part of the code, we're just running through a Dandy set 15 to get all our URLs, and we're setting up a FS-spec model to stream all the data. And then we can just iterate through these files, just downloading the basic metadata that we need, not downloading the whole data, to then create a index table of all the linkages that we want to generate, and all that can sit next to our file to annotate it. And I realize I'm running out of time, so I'm going to leave it with that, and I just want to, at the end, real quickly say, we have a broad range of events coming up that I hope you all will consider engaging with. We're going to have a booth at SFN together with Dandy. We're going to have a tutorial at CoSign next year. We have our developer days coming up in April next year together with DataJoint. And we're also going to have Neurodata Rehack again at Genelia. And if you're interested in hosting an event with us, we're looking for an institute to help us host the NWB user days next year. So please reach out if you have anything.